Dear learner, without paying attention to the science, I want us to focus on the macronutrients. From our previous lesson, we understood that macronutrients are the carbohydrates, the proteins, the fats, or the oil. We actually eat these macronutrients every day, and it is important that we know what they are actually broken down into. That is the end products of digestion, and what these end products are actually used for within our system. And most importantly, what actually happens to the rest of these end products after they must have been used to achieve their purpose. You take, for instance, a glucose molecule that is probably used for energy. After it's being used for energy, what happens to the rest of it that is already absorbed into the bloodstream? And this is where our topic, fasting, is very important, because we are going to see that when we keep eating throughout our lives without giving our body room to deplete the storage of these end products, it becomes a problem. And so as we live, we see the importance of fasting in our lives, because it will actually help us deplete the stock that is in the warehouse. And so we take the first macronutrient, which is the carbohydrate. And what is the carbohydrate according to you? Well, carbohydrates are simply different sugar molecules that do exist either as individual molecules, and here we're talking about the monosaccharides, or exist in pairs, that is the disaccharides, or in some kind of complex form, and here we're talking about the complex sugars. So carbohydrates are of two subcategories. We have the simple carbohydrates or the simple sugars, and we have the complex carbohydrate or the complex sugars. And as I've said before, the simple sugars are the monosaccharides and the disaccharides. What exactly are the monosaccharides? And here I want to say the monosaccharides are actually the building blocks for every other carbohydrate that you can think about. Be it the disaccharides, be it the starch, the fibers, the building block here are the monosaccharides. And the monosaccharides are simply glucose molecules, galactose molecules, or the fructose molecules. These are what we actually call the monosaccharides. Now, the disaccharides are also simple sugars, and they are actually formed from these monosaccharides, as I have just said before. And so when a glucose molecule binds with another glucose molecule, they produce a disaccharide called maltose. When the same glucose molecule binds with fructose, it produces what we call sucrose. And when a glucose molecule binds with galactose, it produces what we call lactose. And so to speak, lactose, maltose, and sucrose are the disaccharides. And now, when the disaccharides, that is lactose, maltose, and the sucrose, when they come together, they form the complex sugars. And so the disaccharides are actually the building blocks for the complex sugars, be it starch, cellulose, or fibers. They are actually formed from these simple sugars called disaccharides. And from this simple explanation, you understand that the monosaccharides, that is the simple sugars called monosaccharides, actually form the building blocks for all the carbohydrates, at the center of which are the glucose. Now, after talking a lot about the carbohydrates, here you look on the screen, you see a variety of carbohydrates. You can have a look, and you look very well. You see things like pawpaw, you see things like bananas, you see things like some vegetables, even what we call okra, and some grains. Most importantly, grains are basically carbohydrates. And we'll come to understand that the grains are actually the complex carbohydrates. And now, the next set of images that you see are images for the simple carbohydrates. And here you see things like drinks, fruit juice, sugar itself in the powder form are actually the simple sugars, and you see a whole lot of other things. And then now, the next one now, you see the complex sugars, which are actually, or the complex carbohydrates, which are actually the healthy carbohydrate, and what we actually advise people to eat in large quantities. Why? Because as you have just seen from what we've explained, the complex carbohydrates are quite complex to break down. And so the sugar molecules that are the building blocks that are found therein are actually difficult to easily arrive at during breakdown. And so the sugar that is contained in it actually is released very slowly. These are what these carbohydrates actually make up the food categories that we call, that we actually say they have low glycemic index. And this year we talk about the maize, we talk about the bananas, and you see the grains and so on. And they are actually the healthy carbohydrates. So, to really summarize what I've been talking about, the different types of carbohydrates, have a look at this image on the screen, and you see the monosaccharides. These are the simple carbs, or the simple carbohydrates. There you have the glucose, you have galactose, you have fructose. And the next image is when glucose, you see glucose binds with glucose, and you see it produces maltose. You have glucose binding with fructose to produce sucrose. You have glucose binding to galactose to produce lactose. And what is interesting here is that at the center of it all, you see the glucose molecule. That is to say, if this particular disaccharides are broken down, they will actually produce at least 3 molecules of glucose and 1 molecule each of the other monosaccharides. And it means glucose is actually at the center of all the sugars that we talk about. So you break down the disaccharides, you have more glucose than any other sugar. You break down the complex sugars, you have more glucose than any other sugar. And so this makes glucose very important, and it is natural because glucose is the main source of energy for animals. Talking about humans, the glucose molecules are our main source of energy. And in the later part of this class, we see something very interesting. We understand that the carbohydrate, irrespective of which form, when broken down, glucose will be available. And what is this glucose used for is what interests us. Glucose in our system is used first and foremost. After it is produced, the glucose, which is the end product of carbohydrate, is absorbed into the bloodstream. And while in the bloodstream, it has to get into our cells and be used up for energy. Now, after the body has used enough for energy, any excess of it is stored in the form of glycogen. You have to understand that glycogen is a complex carbohydrate because it's actually molecules of glucose joined together that actually form glycogen. And so glycogen is a limited storage of glucose molecules. So when we have used enough energy from glucose, the rest of the glucose are actually stored as glycogen. And this actually happens in the muscles and in the liver. Now, there is another storage form because the glycogen is very limited. The rest of the glucose molecules are actually stored in a larger storage form, which are the fats. But a question one might ask is, why these storage forms? Why does our system prefer to store these glucose molecules in the form of glycogen, in the form of fats? Why not just eliminate the excess? And here I want to say that it is just a way to prevent our organs from damage, because excess blood sugar in circulation will probably damage our organs, as we see with the case of diabetic patients where the kidneys are in danger and other organs are in danger. Yes, but not elimination as an option, because our body naturally understands that tomorrow we might be in need of this same glucose for energy, and we might not have food to actually eat and get it from there. And so we have a hormone in our body that during starvation or when we are not eating, some of these storage forms are actually converted back into energy. And that is why our body prefers to store these glucose molecules. And eliminating it naturally will not be good as well, because it will be like wastage of resources. Yeah, you don't just throw away food because you have them, or because you know that tomorrow you will still have. No, you try to store, and that's naturally what our body tries to do. Dear learner, in as much as this storage form is very important and encouraging, it is also very important to understand that life is not all about storing excess of the nutrient, but regulating the storage is also very, very important. Of course, because if at the end of the day the storage is not regulated, it will also create us very devastating health problems, starting from what we call insulin resistance. You bear witness with me that storage of these excess glucose will lead to excess weight gain, overweight, obesity, and some of the fat will actually be deposited in our arteries, creating high blood pressure situations and other cardiovascular problems. And so, with these problems in mind, it is very vital to regulate the way we eat, because if we keep eating without actually regulating, then we will keep accumulating. Our system will keep stocking the stores, the glycogen and the fat, and at the end of the day we'll get serious health effects. And that's why fasting is very important. Fasting is one of the primary measures to actually regulate the way our body stores excess glucose in the form of glycogen and in the form of fats, so that we don't get into health problems. Elena, we have just come to the end of our message on carbohydrates, and I will be very grateful if you can retain these key points. That 1, carbohydrate is a macronutrient that is very, very much available across every community, across every population, because of the importance that it has on our health. Secondly, you should keep it in mind that carbohydrates, when broken down, the principal end product of it is the glucose. And this glucose is used by our body cells to provide us with the energy that we use to move around, to do the talking, to dance, and to do a whole lot of things. And this really shows us the importance of glucose and carbohydrates. You should also keep in mind that once our body has used enough glucose for energy, the rest of it is stored in the form of glycogen. And that glycogen is limited storage, and the unlimited storage form is the fat. And so the excess of all the glucose that our body produces can actually be stored as fat. And the last and very important thing that you have also to retain is that in as much as these storage forms are very important because they enable our body to have the necessary energy later on if we do not have food, we also have to regulate the storage form, as several studies have it that excess fat storage definitely lead to overweight, obesity, and several other health problems like diabetes and so on and so forth. And when you see most of the cardiovascular patients, is because of accumulation of this fat in their arteries and around the heart, and this really poses a problem. And that's why we have to regulate our fat storage. And how do you regulate your fat storage? Through fasting. Fasting is that important tool that your doctor might not be talking to you about, but it has proven very effective. It is the best way to cut down on your weight and to reverse several non-communicable and chronic diseases. So, thank you. We have come to the end of this lesson on carbohydrates. Our next topic is the proteins.